Hello,
Hello, sir.
can you hear me?
Yeah.
Okay. Have you tried the assignment?
Yeah, I barely got any. Like, I tried the first four. It was hardly I was able to do.
First four, as in question one to four.
Yeah.
Okay. Uh, Fine. Did you order the book?
I will. This weekend, my dad was a bit busy.
You need to get the book soon because you have to practice from there. Okay.
Just this weekend, right? Also, sir,
Hmm.
coming Wednesday, is it possible to schedule the class in the morning? Because I'm traveling that day,
Morning
like
what
10
time?
o'clock or something,
Sure.
10:30, something like that.
Yeah, that
Should
will
I
be fine.
type write on group for whoever's
It's
on the
fine. I will message on the group.
okay.
I'll message it. We can do it at 10 o'clock or something. Okay, we'll start discussing what is happening here. So, question one, part one. So, first of all, he's saying translate the graph of the function y is equal to 2x square in such a way that its vertex lies on the graph of y is equal to minus 4x. So, first of all, we have y is equal to 2x square is our function. We have to translate its graph. Translate its graph in such a way that the vertex will lie on y is equal to minus 4x and the distance between its intersection points with the x-axis is 2. Between its intersection points. By the way, the intersection points with the x-axis basically means roots, right?
Right,
Distance between the intersection points with the x-axis is like distance between the roots. That is 2. Because whenever a graph intersects the x-axis, those are the roots, right? Correct?
right,
So we have to find the equation of the translated graph. Find the equation of the question is saying translated function. So first of all, what do you understand by the word translate? Basically, move its graph in such a way that it satisfies the following properties, right? Correct? Do you understand
right.
what I'm saying?
Yeah,
So first of all, before we can move the graph, we have to understand what the graph of this one looks like first, right?
yeah,
This graph, if you plot, it will look like this because you can see it passes through the point 0, 0, right? And you can also label some points on it, like if x is equal to 1, y is equal to root 2. And if x is equal to minus 1, also y is equal to root 2. So these points are 1 comma root 2 and minus 1 comma root 2. Do you understand what I'm saying right now?
right.
Wait, I am making a mistake, I think. If x is equal to, oh, yeah, it is correct. No. Oh, I am making a mistake. If x is equal to 1, then y is equal to 2, not root 2. right? Do you understand? It is actually a little sharper. The graph is like going up higher than normal, like this. When x is 1, y is 2. Can you see that when you put x is 1, y is 2? Similarly, when x is minus 1, also y is 2. Do you
Yeah,
understand the original graph y is equal to 2x square graph? Is it clear what I'm saying right now?
right.
So notice that the separation between these two is like, what is the distance between them? It is 2, no? From minus 1 to plus 1, right?
Yeah,
Okay. Ultimately, I want to shift this graph. Now, right now, both roots are equal because this graph is touching the x-axis. Both roots are equal to 2, right? Equal to 0. This graph is touching the x-axis at 0, comma 0, right? Are you
okay,
understanding?
yes, yes.
So we have to move this graph in such a way that its vertex will lie on here and the distance between the roots will be 2. Correct?
Okay,
So basically, I have an original graph. I need to move it. So it can be shifted in many ways. Like you can shift it to the left, this to the right and up. You can shift it down. There are many ways to translate the graph of a function. Translate the graph. For example, suppose you have y is equal to 2x square. This is my original graph. What will be the graph of y is equal to 2x square plus 1? What do you think is the graph of y is equal to 2x square plus 1?
it's a like
It's the
it's
same kind
like
of graph, but it's slightly above,
just
no?
upper, like
Yeah.
yeah, like
It's just going
its
to shift up, right?
intersection point is y-intercept is 1.
Right. So when x is 0, y is 1 here now, right? Instead of this being 0, 0, it is just shifting up, right? Correct. By 1 unit, no?
Right,
So this is called a translation where you shift the graph up. So if you do y is equal to f of x plus k, then the graph will go k units up, right? Do you understand what I'm saying right now?
okay,
Similarly, if k was negative, what you have done is actually broaden it down, right? If it was y is equal to 2x square minus 1, for example, what would happen to the graph? It would not be here, it will be down here, no, somewhere. Correct?
right,
So in this case, this would be the point x is equal to 0 and y is equal to minus 1, right? Are you understanding what I'm saying?
yep,
Okay, so now notice that we already knew that there were 2 points on the original graph, which were x is 1, then y is 2, and x is minus 1, then also y was 2, right? Correct?
right.
Do you remember that there were 2 points on that y is equal to 2x square graph that we had found, right?
Mm-hmm.
Now, if you look at those 2 points, the distance between them was what? 2, correct?
Yeah.
So think about it. If I shift the graph down by this much distance, by the height of this, basically 2 units, right? If I shift the graph down by 2 units, wouldn't it start looking like this, where these points will cut the x-axis now? Minus 1 comma 0 and 1 comma 0. And the
Yeah.
origin point will go down to 0 comma minus 2 now, right? The vertex, right?
Mm-hmm.
Shift the graph down by 2 units. If I do that, you can see that the difference between the roots is 2 now, right? Do you understand what I'm saying?
Yeah.
These points, which are actually not roots in the original graph, if you bring the graph down by 2 units, they will be the points where they cut the x-axis, right? I hope you are understanding what I'm saying.
Yeah.
So in the question, the second part of the question, he's saying that you have to translate the graph in such a way that the distance between its intersection points with the x-axis is 2, right? So one simple way to do it is just to make the function 2x square minus 2, right? We have shifted the function by down by 2 units, right?
Right.
Can you see that the intersection points are now 2 units apart, the intersection with the x-axis?
Yeah.
Right. Now we have to think of the second part that also has to be true, that the vertex of the graph should lie on the graph of y is equal to minus 4x, right? Y is equal to minus 4x. So the vertex should lie on it. So in that case, so our job is basically not over, because right now the vertex doesn't lie on it, right? 0 comma minus 2 doesn't satisfy this, no? Do you understand what I'm saying right now?
Okay. Yeah.
Right now the vertex has just been brought in down, so it doesn't really satisfy our y is equal to minus 4x equation, because if you put x is 0, y is 0, but here it should come out to be y is equal to 0 comma minus 2 doesn't fit this equation, correct?
Right.
Okay, so for that we'll have to learn about a different type of translation. So far what we have learned is that if you have a graph of a function y is equal to f of x, if you try to draw the graph of f of x plus minus k, it will go up or go down, right? Depending on whether it is positive or negative, correct?
Right.
This is one kind of translation of a graph. Another kind of translation would be, what if I wanted to move the graph to the left or right? Do you understand my question? Suppose my original graph is like this, and I want to shift it this side by 1 unit, right? How do I do that? So I want the whole graph to be shifted by 1 unit to this side. So instead of 0, 0, vertex should be at 1, comma 0. Do you understand what I'm trying to do?
Yeah.
So suppose this was my original function y is equal to x square. What if I want to move it to the right by 1 unit? Think about it. If you wanted to shift 1 unit to the right, you should replace x with x minus 1.
X minus. Okay.
Minus. Think about it a little bit. If I wrote this function now, x minus 1 whole square, See that 1 comma 0 will satisfy this function.
So if it is going to the right side, then it's minus. And if it's going to the left, it's
Huh.
plus.
To shift the graph, you need to replace x with x minus k or x minus something to go to the right. But if you want to go to the left, you should have written y is equal to x plus 1 whole square.
Plus one.
Because
Yeah.
notice that if you have y is equal to x plus 1 whole square, the vertex will happen when x is minus 1. No?
Okay, and that's inside the brackets. But if we want to go up and down the axis, then it's
Huh.
outside the bracket and
Huh.
uh,
Here we
up.
are, here we are replacing x with this. And here we are adding something to whatever was originally the function, right?
Right.
Because we want the y value to change. We don't want the x to change, right?
Yeah,
Do you understand what I'm saying?
got it.
You can see clearly that x minus 1 when you do, it is at 1 comma 0 that it will touch the x-axis, not at 0, 0, right?
Yeah.
So basically a left shift or a right shift can be done by doing x has to be replaced with either x minus a or x plus a, right? And if you want to go up and down, then you should take your original function and add something to it, right? Do
Got
you
it.
understand?
Yeah.
Okay. So now that we know how to move the graph left or right, up or down, now we will think about, okay, maybe in our original function, we already know that we have to bring it down by 2 units because that will make those 2 points as the roots, right? Which were earlier above, right? Do you understand what I'm saying right now?
Yeah.
See, these 2 points are on the original graph and they have a separation of how much? 2, correct?
Yeah.
If I want the roots to be having a separation of 2, I need to bring this whole thing down by a little bit, right? By 2 units because this height is 2, correct?
Yeah.
So that step is correct, but it might not be enough. Maybe we don't just need to pull it down, we also need to shift it left or right, right? Do you understand?
Yeah.
You can do both the operations simultaneously. You can shift it up and down also and left and right also. So for example, suppose I don't know whether it has to be shifted left or right. Right now I'm clueless about it. Okay. So what I'll do is instead of x, I'll replace it with x minus h. I don't know whether this is positive or negative. Okay. H is unknown. Do you understand what I'm saying?
Yeah.
If it was positive, then it is a shift to the right. And if it was negative, it is a shift to the left. Correct? Think
Yeah.
about it. If it was x minus 1, it would have shifted 1 unit to the right. Right? In that case, h is 1, which is positive. Right? But if h was minus 1, it would be x minus minus 1, so x plus 1. So in that case, it would shift to the left side. Correct?
Right.
Uh,
Got it.
so if I do this operation, my equation will become 2 times x minus h whole square, right? This is just
Yeah.
a shifted graph, but it is only a left or a right shift, right? We still have to bring it down, okay? So we bring it down by doing minus 2 as we saw earlier, right? Correct?
Right.
We bring it down by doing this. Now, I'm going to say that this graph should satisfy both of the properties that the question is asking us to. Second property, it is automatically going to satisfy because by bringing it down, we have made this as the distance between the roots. We now need to check whether the vertex lies on y is equal to minus 4x. I mean, we have to find the value of h so that that always happens. Do you understand what I'm saying right now?
Yeah.
So, in order to find the vertex of this one, what we can do is maybe just simply think about it like this. If I shifted it by h units to this side, then my vertex is now at what? See, earlier if you bring it down, the vertex was at what? 0, comma minus 2, right?
Yeah.
But now I have replaced x with x minus h. So I've shifted it by h units to this side, right?
Right.
So the vertex is now at h comma minus 2, right?
Yeah.
Do you understand how it has gone from 0, 0 to h comma minus 2?
Right.
So we have to say that this h comma minus 2 should lie on this, no?
Yeah.
So we'll say minus 2 is equal to minus 4 into h. So h is coming as half, right? Correct?
Right.
So now you will get the equation as 2 times x minus half whole square minus 2. And let's think about that for a minute. 2 times x minus half whole square minus 2. Let's simplify this and understand whether it is satisfying our problem's conditions or not. So this becomes 2 times x square plus 1 by 4 minus 2 into half into x minus 2, right?
Yeah.
So this is 2x square minus 2x plus half minus 2. So it will be minus 3 by 2, right? Are you understanding that this is my final function?
Okay. Yeah.
I hope everything is clear so far what I am doing.
Yeah.
So now look at this function. We can easily find the roots of this function first of all. So roots will be 2x square minus 2x minus 3 by 2 is equal to 0. So x will be equal to 2 plus minus root over b square. So 4 minus minus. So plus 4 times 2 times 3 by 2 divided by 2 into 2. I'm just finding the roots of this quadratic. Okay. So this is 2 plus
Okay.
minus root over. See, it is 12 plus 4, 16, right? Do you understand what I'm doing right now?
Yeah.
So it is 6 by 4 or minus 2 by 4. So basically it is 3 by 2 or minus half.
Minus half.
Can you
Yeah.
see that the difference between them is 2,
Yeah. Okay. Yeah.
right? Also, now if this was my quadratic, y is equal to 2x square minus 2x minus 3 by 2, then my vertex of the quadratic will always be at x is equal to minus b over 2a, right? Correct? X
Yeah.
is equal to minus b over 2a. In this case, minus our b is minus 2 over 2 times 2. This is 2a, right? So notice that this is plus 2 by 2 into 2. So x is equal to half, right?
Right.
Vertex is at x is equal to half. Let's find the y value at x is equal to half. So y is equal to 2 into half square. So 1 by 4 minus 2 into half minus 3 by 2. So this is half minus 1 minus 3 by 2, right? So can you see that y is coming out to be minus 2? Do you
Right.
understand y is coming as minus 2 for here? So our
Yeah.
vertex is at half comma minus 2, right? Right?
Right.
And see that this satisfies the equation y is equal to minus 4x. This vertex is definitely lying on this. When you put minus 2, it is equal to minus 4 times half. right?
Right.
So what have we like learned from this question? The first thing we have learned is how to translate the graph up or down or right or left, right? So for up or down, if I have y is equal to f of x, what should I do?
Sorry, for which one?
For
Like,
up or down translation, what should I do if my
then
original function was y is equal to f of
it's
x,
fx plus or minus
some
k.
constant, right?
Yeah,
And for right and left, what should I do to y is
it's
equal to f of
x
x?
plus something something, like constant.
So what should my function be? Y is equal to f of
F bracket x plus
x
minus
plus a or
something.
x minus a.
Yeah,
You have to replace it with x plus a or x minus a instead of x, right? If you
right.
do x plus a, the graph is shifting to the left.
Left side and
This
negative
is going
is
to the right.
right.
So in this
Right.
problem, we took the graph of 2x square and we did both the things. We said first we made it down by 2 and then we did it 2 into x plus h or x minus h whole square minus 2. We didn't know h value, but we know that finally the vertex lies on y is equal to minus 4x, right? Correct?
Right.
This was the up or down shift, and this was the left and right shift, right? Correct?
Right.
So when you do here, the original vertex was where? 0, 0, right?
Yeah.
When you went down, the vertex came at 0, comma minus 2 here, right? Right?
Right.
And then you went to the right because you did x minus h, right? You went to the right by how many units? H units, right? Do you understand what I'm saying?
Oh, by what? I didn't get it.
What did we do in the problem? How did we solve and find h?
Wait.
We have already finished discussing the problem. This is just me revising it. Now you're saying that you don't know what we did. When you don't understand something, you have to ask immediately. You don't have to wait silently and pretend that you got it.
No, no, I just got confused.
So what do we do? How
Uh,
do I find h?
we are moving h times like towards the right. So we did it as x minus h in the function, and then mm, we did what? Yeah, we put it in the equation like 2 bracket x minus h whole square 2 minus 2, which gave us minus 2 equals to minus 4h, and h is half then.
No, but how did you get minus 2 is equal to minus 4h?
The y is minus 2.
How did you know what is x?
How did we know what is?
The equation that you are saying which gives us h, how do you get that equation? Minus 2 is equal to minus 4h. How did you get that equation? From where did it come?
from this 2 bracket x minus h whole square minus 2.
But you're not giving me any reason. You're just saying it came from here. How? Explain.
Because it's like y equals to 2x square. So it's 2 whole square, this x minus h whole square 2.
I know how this equation
Like,
has come. I want to find you to tell me how the equation minus 2 is equal to minus 4h comes. Or why is it correct? Why is this equation going to be right? Pay attention right now. You don't know it. The original graph was this. Here the vertex was where? This was the vertex.
right.
We shifted it down first of all. Then the graph became what? Went down a little bit. What would be the vertex now? What is the
Um,
vertex of this graph?
it's minus 0 comma minus 2.
Because you have moved it down by 2 units. Then
And
on
then
this
we shift
graph,
it
we are shifting it by
to the
doing
right. So it's h comma minus 2.
right. We are taking it and going into the right by h. So vertex is h comma minus 2. And the question has said that the vertex should lie on that line, right? Correct?
Yeah,
So our h comma minus 2 should satisfy this equation.
yeah.
From there, I am getting minus 2 is equal to minus 4h. Do you understand?
Okay,
Basically, this question is telling us ki how to translate a graph. That is the main thing to learn from the question. Okay,
okay. Yeah,
fine. Let's move on to the second one. Suppose a can be any real number between 0 and 5, including the endpoints. So basically, 0 is less than equal to a, less than equal to 5. A can be anything between 0 and 5. Then the number of integer values of b, then the number of integer values of b such that what is the equation? 3b is equal to a into a minus 8 for some a is what? Basically, the question that they're asking is how many integer values of b will satisfy an equation like this? Correct?
right.
Where we know that a is any real number, a is any real number between 0 and 5. And we know that b has to be an integer. Correct?
Yeah,
So how many such integer values of b are possible basically? That's what they're asking. Okay, so let's look at it a little bit. 3b is equal to, let's multiply it and we'll get a square minus 8a, right?
right.
Now this a square minus 8a, we can actually figure out that what is the upper limit and lower limit of this when a is going from 0 to 5? You can figure out the total values that it can take, right? How can I figure that out? Because this is like a quadratic in a, right?
Yeah.
If it's a quadratic in a, we can try to draw the rough graph of this quadratic. The graph of this quadratic, notice it's an opening upward type of quadratic, right?
Yeah, and the intersect, the y-intercept is 0. Right.
Not the y-intercept. You have to look at where the roots of this graph will be, right? If your graph is y is equal to x square minus 8x, it is clear that it is x into x minus 8. So roots are x is equal to 0 and x is equal to 8, right?
Yeah.
So if you think about it, the graph should look something like this. Notice that this is your 0, 0, and this is your 8, comma 0, right?
Right.
Correct. This is my values. This is my graph of this whole thing. A square minus 8a, right?
Yeah.
And if a is going from 0 to 5, so our a values are going from 0 to 5. Notice that this was value of a was 8 here, right? 5 will be somewhere here, no? Do you understand what I'm saying right now?
Yeah.
So a values are going from 0 to 5. In that region, the graph is actually down. No, see, it is downward here. It is on the negative side of the below the x-axis, right?
Right.
Do you realize that the vertex will be at some point where a is 4? Do you realize vertex will be midpoint of the roots? No, it's the symmetry point, right?
Yeah.
So we can easily guess that 4 is the minimum point of this graph, minimum, right?
Yeah.
And the highest point of this graph will be where? At 0, right?
Right.
And after 4, it is starting to rise up again because it has to go up to 5. But already those values have already been taken, no, on the other side.
Right.
So basically, what I'm trying to tell you is that we can predict what is that set of values that this right hand side can take. Right hand side can be what? We can predict that by looking at the graph of the quadratic, right?
Yeah.
So the y values will tell us the values of a square minus 8a, the y values. So you can see the maximum y value is 0, no, here, right?
Yeah.
And the minimum y value, do you realize that it will happen at the vertex at 4?
Right.
So if you put a is equal to 4 here, you'll get 16 minus 64, right? So minus 48. No, I'm making a mistake. 16 minus 32. So minus 16, right? Do you understand what I'm saying right now?
Yep.
What I'm saying is that the quadratic, when a goes from 0 to 5, can take values anywhere from 0 all the way down to minus 16, which is this one. Correct?
Right.
So that's it. That will easily help you find b, no? Because 3b is supposed to be all of that, right? You will you will say that because a square minus 8a is between minus 16 and 0. Can we say this correctly? Is this making sense to you that we can say this?
Yeah.
When 0 is between a and 0, a is between 0 to 5. This is guaranteed,
Right.
right? So then automatically we can replace a square minus 8a with 3b and say minus 16 is less than 3b less than 0, right?
Yeah.
And we can get something like this. B ranges between minus 5.33 to 0, correct?
Right.
So the integer values of b will be what? B can take 0, -1, -2, -3, -4, and -5, but it cannot be -6, correct? All the integer values of b between this. Do you understand how we are doing it?
Yeah, got it.
We are relying on the graph of the quadratic a square minus 8a, and we are looking at the graph when a goes from 0 to 5 to figure out what are the possible values of the whole a square minus 8a. If you look at the graph
Yeah.
and draw the graph, you will realize that the minimum value possible is when it is at the vertex. That point happens to be at a is equal to 4. The maximum value possible is when it cuts the x-axis, and which is happening when y is equal to 0 and a is also 0 there. So the y values, the output of that quadratic can be anything between minus 16 and 0. And since that has to be equal to 3b, you get the range of values of b also, right?
Yeah.
The answer here is 6 because there are 6 integers in these b values.
Right.
There is another way to solve the problem also, which does not involve a graph, but it involves algebra way. So you can say like this. This is the situation. We have to find possible values of b. B has to be integer. And we know that a is anything between 0 to 5. So what we can do here is a square minus 8a is equal to 3b. We can bring it to this side. Minus 3b is equal to 0, right?
Right.
Correct. And then we can say that this is a quadratic with variable a. Instead of x, it's looking like a quadratic with variable a, right?
Right.
So the solution of this quadratic will be something like this. A is equal to, you will do the formula, right?
Yeah.
The formula will look like this. Minus b is going to be plus 8 plus minus root over b square, which is 64, minus 4 times 1 time minus 3b. Minus 3b is my c, correct? Do you understand what I have done so far?
Right.
So you're getting 8 plus minus root over 64 plus 12b divided by 2, right?
Right.
A is equal to, you can cancel the 2 and write 4 plus minus. From here you can take 4 common and this will come out as a 2. Once it comes out of the square root, it will become a 2 and 2 will cancel with the denominators 2. So you will get inside 16 plus 3b, right?
Right.
Okay, great. So if A is like that, now think about it. A was supposed to be real, na? Question had said A was a real number between 0 and 5, right?
Yeah.
So A can be a real number only if 16 plus 3B is greater than equal to 0, right? Correct?
Yeah.
Because the thing inside the square root cannot be negative if A has to be real.
Yeah.
So then from here we are getting 3B is greater than equal to minus 16 and B is greater than equal to minus 16 by 3, right?
Yeah.
So we automatically get one side of the thing that we already knew. Do you remember that we had written minus 16 by 3 is less than equal to B less than equal to 0 there?
Yeah.
So one side we have already gotten, right?
Right.
Correct. We can also get the other side uh, by realizing that if A is between 0 to 5, A is supposed to be between 0 to 5. So A is supposed to be positive, right?
Right.
Correct. If A
Yeah.
is supposed to be positive, uh, we can't take this negative sign, I think. Correct.
Right.
One second, let me think. B could be negative also. Why is B supposed to be negative? Because
But it needs to be real number, right? It can't be negative within the
no,
root.
B itself can be negative. The whole thing has to be positive. That's what I want to figure out. Why is B supposed to be less than equal to 0, right? That's the missing condition so far. Correct?
Yeah.
So what I'm saying is, uh, in the portion between 0 to 5, this whole right hand side is going to be negative. Why? Because A minus 8 will be negative, right? Because A is less than 5. But this part is positive. Do you understand? In 0 to 5, A is positive, but A minus 8 is negative, no?
Okay, yeah.
So the
Yeah.
product of these two is itself negative, right?
Right.
So that automatically means that 3B is less than equal to 0.
Yeah, so B is negative.
Hmm. So we got B is less than equal to 0 immediately, and we already got B is greater than minus 16 by 3 for A to be real, right? Correct?
Right.
That we got by making a quadratic in A and then solving that quadratic and saying that for A to be real, the discriminant should be positive, right? The thing inside the root should be positive.
Yeah.
So now both the inequalities we have gotten, no? B less than equal to 0 and B greater than equal to this.
Right.
Correct? So this is the pure algebra way where we didn't say anything about the graph and all, right? But there is a graphical way also, which we did earlier. We said that we'll just draw the graph of the right hand side. It looks like a graph like this. And our A values are supposed to be between 0 to 5. So 5, the vertex here is at 4 comma minus 16. So 5 is somewhere here. So I have to keep track of the values of the function up to here, right? From 0 to here. Correct?
Yeah.
The minimum value of the function will be at the vertex. So it is minus 16 minimum. Maximum value is clearly at 0. So our right hand side is between 0 and minus 16. I'm writing it in the opposite way. You should write like this. And that information came to us from the graph, from looking at the graph, right? Do you understand?
Yeah.
And we replaced right hand side with 3b and we got the same minus 16 by 3 less than b less than equal to 0. And now you have to just count which integers fall in this range. So I've shown you two methods. One method was pure algebra, one method is by graph.
Yeah.
I hope you are understanding.
Yeah.
Okay. Now, question number 3. Why don't you try it a little bit now? Based on what you have learned in question 1 and question 2, now you can think about question 3 a little better. So it is saying, suppose this is question number 1, part 3. Okay.
Yeah. Yeah. Okay.
Suppose f of x is equal to ax square plus bx, and they are saying 1 is less than equal to f of minus 1 less than equal to 2. And they are also saying 2 is less than equal to f of 1 is less than equal to 4. Now they are asking us for the value range of f of minus 2. By value range, what they mean is what is the range of possible outputs of f of minus 2. For example, here he has given the range of these values, right? F of 1 and f of minus 1, right? You have to similarly find p is less than equal to f of minus 2 is less than equal to q. You have to find p and q. Do you understand what I'm saying?
Yeah.
Okay, so now try it out and try it out yourself. The best way to approach it is to figure out what f of minus 1, f of 1, and f of minus 2 actually look like. So f of minus 1 is what? You have to put minus 1 into this, right?
Could you give me like 1 minute? I think like I'm trying. Think I
Okay,
got it.
fine.
Okay, okay. I think I got it. Hello? Hello?
Yeah, I was on mute. Tell me how.
Right. So, firstly, one second. Minus one. Yeah, so firstly I put minus one in the like the quadratic equation, and
Hmm.
it gives a minus b. Then I put one, which gives a plus b. Now I thought to do it like simultaneous sort of. Like I added both the equations. Like
Mm-hmm.
it's 3 greater than equal to 2a greater, sorry, less
Right.
than
So
equal to 6.
basically you have inequalities like this. One is less than equal to a minus b less than equal to 2. And you have 2 is less than equal to a plus b less than equal to 4. Right?
Yeah, and now we add both of them,
Hmm.
both the equations.
If you add these inequalities, what you end up getting is 3 is less than equal to 2a less than equal to 6. Right?
6. Yeah, which is 3 upon 2. Right. Yeah.
So we
And
get
then
this now.
we can also subtract, like since we do both in simultaneous, uh, we subtract and we get 0 less than equal to 2p less than equal to 3.
Wait 1 second. Uh, you are subtracting the inequalities.
Yeah,
Uh, I'm not sure whether that works here because it's inequalities. No, it's not equations. 1 second.
I think I'm
Let's
onto something. Can we try that, please?
what?
Like the subtracting part.
No, we can't try it unless we are sure whether we can do it or not, whether it's logical. They are
We get
inequalities. No,
a
they are not equations. If it was equations, I could have done whatever.
But we like my thought process for subtracting and adding was because if we add, then we get a, like we can find a range for a. If we subtract, then we can find a range for b.
That's fine, dude. But is it allowed to subtract inequalities? That's the question.
Why not? We just added. We can't subtract.
Addition is obviously correct because when you add x plus y, 1 plus 2 is less than 2 plus 3. How do you know x minus y whether it is correct or not? There will be complications when you subtract because when you put a minus sign, the inequality reverses the sign. Do you understand what I'm saying right now?
But that's within the inequality. Like we are doing subtracting two different inequalities. Like I don't know. I thought it made sense.
It could be right, but I'm not sure. You have to check that because here, if you change the sign of this inequality, you make it minus 2 greater than minus y greater than minus 3. And then you add, you can
Why?
write it as minus 3 is less than equal to
Where
minus
did
y.
X and Y come from?
I'm taking an example to try to understand whether subtraction works.
Okay, okay.
We have minus 3 is less than 1 second. Minus 3 is less than equal to minus y is less than equal to minus 2. If I put a negative sign, the inequality reverses its sign. And we already had 1 is less than this. Now if I add 1 and this, I'm getting minus 2 is less than x minus y is less than 0. So clearly it doesn't work. If you had directly subtracted, you would have gotten -1 is less than x minus y is less than equal to -1, right?
Okay.
The reason it doesn't work is because when you do a negative sign, the inequality reverses the sign. You cannot randomly connect multiple inequalities. What's the
How did we get
problem?
-2 and -3 and all that?
Because we multiplied by -1. Because I want to see whether x minus y will give us the same thing. X minus y is same thing as adding x plus minus y.
Yeah.
What are you getting when you subtract it? What did you get for b?
I got like the range is 0 less than equal to p less than equal to 3 upon 2.
How? Which ones did you subtract?
The the same equations.
Equation 1 minus equation 2 or equation 2 minus
Matlab,
equation 1?
uh, first minus second.
That will give you minus 2b, by the way. This is what we are getting.
No, no, 2 minus 1. Sorry, sorry, sorry.
You only don't know what you have done.
Sorry. I got confused.
So what are we getting now from here? Is this what you're getting? You have gotten
Never
something
mind.
else.
Yeah, I must have done something wrong. I think I got confused.
This is what we are getting, and in this case, it is correct because we can get the same answer even without subtracting. If I know the range of A, which was obvious, I can say that A plus B will vary between 3 by 2 plus B to 3 plus B, right? Do you understand what I'm saying?
Right.
Because A is going between 3 by 2 and 3. So obviously A plus B will be between 3 by 2 plus B to 3 plus B, right? Correct?
Yeah.
And then we have to say that this whole thing 2 is less than equal to 3 by 2 plus B, and we can say 3 plus B is less than equal to 4 because A plus B was going between 2 to 4, right?
Yeah.
So from here you will get B is greater than half, and from here you will get B is less than 1.
Right.
But the problem is that if B was negative, then we should have checked the other side because 3 by 2 plus B, we don't know which one is bigger out of these then. 3 by 2 plus B or 3 plus B, right? Wait, do we know that already? Yeah, we know that. Okay, 3 by 2 plus B is always smaller than 3 plus B, so then this is correct. 3 by 2 plus B is clearly always smaller than 3 plus B. So we should always check the lower limit with this lower limit 2. Notice that in that case also we are getting half is less than equal to b, and here you're getting b is less than equal to 1, right?
Right.
So ultimately we are getting the answer that a's range is 3 by 2 to 3 and b's range is half to 1, right? Correct.
Right.
So now our question is to figure out the range of values of 4a minus 2b. So that is easy. We'll just write 4a. First of all, we'll get the range of 4a. It will be 4 times this. So 6 to 12, right? Correct.
Right.
And 2b's range will be 1 to 2, correct?
Yeah.
So what will be when we subtract 4a minus 2b? The maximum possible value of that will be when we pick the highest value of 12 and subtract the lower limit of 2b. This is why I was saying that we should not directly add and subtract directly. Do you understand that right now if you directly subtract without thinking much, you will get a wrong answer?
Yeah.
That's why I was saying you don't do directly without thinking. If I do it blindly right now, 4a minus 2b, according to the normal things you would do is what? 5 to 10. That is clearly wrong, right? Because you have to subtract upper bound and lower bound, not the other way around.
Yeah.
What I'm saying is the maximum value of 4a is 12, minimum value of 2b is 1. So the maximum value of this expression will come when you take the biggest possible value here and smallest value here, right?
Right.
It will be 11. And the lowest value will come when you take the smallest value of 4a and the largest value of this, correct?
Yeah.
Which will be 4. So 4 to 11 is the correct answer. But if you blindly subtract, you will get 5 to 10, which is clearly wrong. Do you understand what I'm saying?
Got it.
That's why I was hesitant on subtracting.
Okay. Yeah.
Subtracting is not reliable because negative sign will change the sign of the inequality. Addition is fine as long as all the inequality signs are similar, you can add. Do you
Right.
understand? Because you always have to add lower limit with lower limit and upper limit with upper limit. But when you subtract, see what has happened here. Correct?
Yeah.
So 4
Makes
to
sense.
11 will be the range for this.
Got it.
If you do without carefully thinking about it, you will say 5 to 10. That will be wrong. I hope you understand what I'm saying.
Right.
Okay. Question number 4 then. Suppose the quadratic function f of x is equal to ax square plus bx plus c attains the maximum value 10 at x is equal to 3. F of x is equal to ax square plus bx plus c attains maximum value of 10 at x is equal to 3. Okay, great. They have also told us the distance between intersection points with the x-axis. We know what that means. It means distance between the roots, right?
Right.
Okay. So we know distance between the roots is 4. They are asking us for f of 1. This, if you have understood the 3 questions we have done so far, you should be able to solve this yourself. It's not very difficult. Think of the graph. I think you should be able to solve it.
Okay, let me try.
Hmm. Are you getting
Not
something?
sure.
No, you
Not
are
sure.
giving up too easily. That's not allowed to give up. You already know, we have already discussed all this theory. You can't give up so fast. What do you mean you're not sure? What information have you figured out from these things? You have to unmute yourself and tell me, what have you figured out from the first sentence?
So if x is 3, then y will be 10.
That's not enough. More information is there in that. Is it a random point or is it a special point?
Was it special?
What is special about it?
It's a maximum. So it
Mm-hmm.
will be like it will be a U type curve.
Mm-hmm. U-type curve.
Like
U.
uh
Is that a maxima?
it is, no?
Is it a U-type curve or a different type curve where you will get a maxima? Is this point a maxima?
No. Yeah.
This is the maximum value or it will be minimum value, dude.
Bad.
Why are you saying obvious things wrong? This is clearly a minimum, no.
Yeah.
What kind of curve will have a maxima in a quadratic?
The opposite one, like the upside down.
Maximum will happen at the vertex,
Yeah.
just like minimum happens at the vertex. The vertex is basically given to you as 3 comma 10, right?
Yeah.
That's a lot of information. What is the x coordinate of the vertex? What have we learned?
X code. Sorry.
What is the x coordinate of the vertex of a standard parabola?
Minus b upon 2a.
So is the x coordinate here known to us?
Yeah.
So can we equate that to 3?
Right.
So did you write this equation when you were trying?
Uh,
So you were not using the information that we have already discussed in the previous couple of classes. This has been discussed no multiple times.
yeah.
Then you can also do, if you put x is equal to 3, y will be 10. So you can do 10 is equal to 9a plus 3b plus c, right?
Right.
We have already gotten two equations. Now we have to use the other information. Distance between the roots is 4, right?
Right.
Okay. So how can we use that? This distance is supposed to be 4.
So if x equals to 0, then
Hmm.
um
This point will be, let's say one point is alpha comma 0 and this point is beta comma 0, right?
Right.
The difference between alpha and beta is 4, right?
Right.
You can already, from this vertex, you can already see that the roots will be 5 and 1.
How?
Look at the graph. What was the value of x at the vertex?
3.
You don't know that vertex is the line of symmetry.
Yeah.
So if the distance between the
Okay.
roots is 4, wouldn't one root be 2 units this side, one root be 2 units this side?
Yeah.
Do you understand why it is coming 5 comma 0 and 1 comma 0?
Yeah.
Now you know both the roots are 5 and 1. 1 and 5 are the roots. Can we do Vieta's relations and get alpha plus beta is minus b over a and alpha beta is c over a?
Yeah.
Alpha plus beta is 6, which is, by the way, the same equation that we got from here. See? Can you see that this is also 6 is equal to minus b over a?
Yeah.
Which is the same thing that is coming here. But this gives us additional information because product of the roots is 1 into 5 is equal to c over a, right?
Right.
Are we getting a third equation now? C by a is 5.
Right.
Is it clear to you or you are just saying yes?
No, no, it's clear.
Now we have three equations. From this equation, we can say b is equal to minus 6a. From this equation, I can say c is equal to 5a. And both of these things I can put in this equation and I will say 9a plus 3 times b will be minus 18a plus c, which is 5a. Total is coming out to be minus 4a is equal to 10, right? Correct.
Right.
A is coming out to be minus 5 over 2. And if A is known, now B is minus 6 times A. So that will be 6 times 5 by 2, so 15. And C will be 5 times A, so minus 25 by 2. Correct?
Right.
F of 1 is simply, if you find F of 1, it is simply A plus B plus C. So we have to calculate A plus B plus C. So add all of it. This is 5 by 2 plus minus 25 by 2 is clearly minus 30 by 2 or minus 15. And that cancels the plus 15. So A plus B plus C is equal to 0. By the way, notice that we actually didn't need to find also A plus B plus A, B, C. We didn't need to find also. You know why?
Right.
We didn't have to solve all of these equations also actually. As soon as we got the quadratic and we noticed that 3 was our vertex and two roots were equidistant on either side, I already got 1 was a root, right?
Yeah.
So f of 1 is 0, no? Directly.
Oh.
Do you understand that without solving ABC also I can say from the graph only?
Yeah.
1 is a root because it was 1 and 5 were roots because the vertex will symmetrically divide the quadratic into two halves. Correct?
Right.
So since 3 x is equal to 3 was vertex, so 5 and 1 are roots. So if 1 is a root, then f of 1 is 0. Although we actually found out ABC also by writing all the information, we got three equations. In two of the equations, we wrote B and C in terms of A, and then we put that in the third equation. So we have done it normal way also, but directly also you can say f of 1 is 0. Is that clear?
Right.
So the four questions that we have discussed, like all the theory that you really need, we have done the basic theory. Now it's about learning how to apply the graph and not giving up in 2 minutes. Do you understand?
Right.
In the rest of the questions, I want you to put in a little more effort. Don't like give up. We have already discussed the theory. If you try it a little bit and try multiple times, then when you see the solution, you will learn. Otherwise, all of this will be forgotten in 2 weeks. Anybody who is like not really trying himself and just listening to someone else solve the question is going to forget everything that was discussed. That's a guarantee. In 1 month, you'll forget everything. The only way to remember is when you have yourself struggled with the problems. Then, when you see the solution, it opens up something in your mind. Do you understand what I'm saying?
Got it.
So, what I want you to do is from today's class, whatever we solved, four problems, you need to now work on the remaining ones. Don't assume that they are very difficult or something. It's not necessary that they are very difficult. These 15
Right.
problems will teach you everything that you need to know. So don't be scared of them. Try it out, see how much you can do. Tell me exactly where you are stuck. If somebody comes to class and says, "Sir, I didn't get anything," that's not a very like positive thing to say, or that's not a very useful thing to say to the teacher. What you have to say is, "Sir, in question 3, I got this, but then I'm not able to find another relation to find how to get f of 2." Do you understand the difference?
Yeah.
If you say in the next class that I didn't get anything, then I'm going to ask, okay, tell me what you have done in question 2 and where you are stuck. Exactly where you are stuck, what all have you already found? Do you understand what I'm
Okay.
saying?
Yeah.
So don't give up quickly and see that whatever you have learned so far, whatever we have discussed, you use all of that knowledge. The graph of a quadratic is super important. Knowing the properties of the vertex is at x is equal to minus b by 2a, vertex is symmetrical, divides the parabola into two equal halves. All of these facts are useful, and only by solving problems you will be able to learn how to use them. Okay?
Right.
Try it out, and we'll go through all the questions once you have attempted a few more of them. Also, order that book. Okay.
Yes, I had a question. So,
Hmm.
I searched it up on Amazon and
Hmm.
there's a yellow book and a blue book with the same name. Which one is it? Like, which one are we supposed to buy?
Yellow book. Okay. Message me the links on WhatsApp or something. Right. Uh,
Okay.
Whatever links you're confused by, just message me the links. I don't know about yellow or blue and all, but there is only one book, the test of mathematics at 10 plus 2 level. It's for ISI-CMI exams and all. It's a standard book only. Maybe they have made some solutions or some. I don't know. You will have to share
Editions,
the
I think.
link. Huh?
Editions, I think.
Doesn't matter. We just need a practice resource. Okay. So just send the two links to me once. I will look at it and then you can decide. Then I'll tell you which
Right.
one you should get.
Okay. And Wednesday, so like it's
Morning we'll
Friday.
do.
Okay.
Wednesday morning we can do at 10.
Okay.
Okay, fine.
Thank you, sir. Bye.
Bye.